Okay, go ahead.
Okay. So again, welcome to everyone here. I hope you're all in the correct class. This is pneumatics for FRC. I don't know if FLL really does pneumatics, but anyhow.
Nope.
Anyhow, first off, my name is Harrison Ford. A small background on me. I am not the Harrison Ford. I do not fly planes. I do not crash them. I do not, teach people Han Solo references or anything else in between. I accept those, but I do not teach those. Also, I am a Kettering alumni. I graduated this past year, 2016, so good for me. I also work at FIRST Robotics of America over in Rochester Hills, Michigan. I am currently a mentor for a team 322 Flint Fire. That's my first affiliation for now. Been in FIRST for, 2016? Been in FIRST for 12 years now, since I was in elementary, so I kind of have I have a bigger aspect of FIRST than most, but at the same time, FTC wasn't around when I was in elementary. So let's move on to where we're going to be going. So the goal for today is I'm going to make sure you understand the pneumatic advantages, familiarize you guys with your pneumatic products, and learn how to assemble them all together. And again, as I told some people, a lot of people just walked in. At the end of the presentation, I will send this presentation out to all who want it. Plus, I will give you a detailed FIRST pneumatics guideline. That way, it'll be easier for you to build it. But seeing it is believing, I guess. So first, we're going to start you off with the pneumatic control module, or the PCM. PCM basically is your brain for all your pneumatic systems. This PCM connects itself to a Robo-Rio as well as the battery itself. So to start off with, you have I gotta walk over here. First thing about the PCM that is very important altogether is that this PCM, even if you have all your pneumatics hooked up to it, will not run until the CAN bus interface is wired into the PCM. That is the only connection that it has to the Robo-Rio. Meaning that even if you code, whatever you code in LabVIEW, Java, C++, you do not have the CAN bus interface connected from the Robo-Rio to the PCM. Just made pneumatics for nothing. Sorry. So another thing you have, I believe it's, I want to say it's 12. It's either 12 or 14. But you have 12 or 14 slots of your 12 to 24 volt solenoid channels. We'll go through solenoids a little bit later. You have a 12 volt or a 24 volt output jumper, which is located in the center of the PCM. So whenever you guys put together pneumatics, it has to go through either a 12 volt or a 24 volt jump. You cannot hook up a 12 volt solenoid to a 24 jumper. You have to go 24, 24, 12, 12. You can do like a 5 volt jumper to a 12 volt jumper, but you have to kind of play around with it a little bit in order for that to happen. That'll be something that you guys can go through. So, as Mark is passing that around, you guys can kind of see what you'll be kind of learning for the end product. Just basically putting a whole entire pneumatic system together. Over here to your left side of the PCM controller, you have your pressure switch direct wire, which are these first two to the left. And right after that, you have your compressor out. So your compressor and your pressure switches have to be connected in order for the full thing to run. You do need a pressure switch every time that you create a pneumatic chain, because that's actually part of the rules. So no pressure switch, then you might get flagged down. Mark can probably tell you a little bit more about that than I can, honestly.
Yep. Things that we check for.
So in the center, you also have your status. You have your status lights, and you have your comp lights, which are basically the communication rather than the status. So, like I said, if your can is hooked up, you have really nothing to worry about. And then this is where your 12-volt battery basically gets its juice from. In a few minutes or so, while we're going through everything, you'll see how all of it's put together. So let's move forward. First off, everyone, I'm gonna literally go piece by piece. So you might get annoyed with the fact that it may sound like I'm reiterating a lot of stuff, but it is very important and it does help you guys in the long run. So first things first is the compressor. The compressor starts you out with 120 psi approximately. You can't go any further than 120 psi. You can have compressors that are compatible with FRC robots, but it has to follow the exact same specs that FRC has regulated. This is the old compressor from back in the day.
It weighs about 3 pounds more.
Yeah. So I just want you guys to know these are the compatibilities. You connect that to the compressor out of the PCM. It's pretty self-explanatory. It can be mounted on or off board the robot, basically saying that you can mount it directly to the board, just like shown here, and then you can mount it off the board, which is somewhere else on the robot. So as long as it's placed on the robot in a secure fashion, you can basically go wherever you want to go with the compressor. Yes.
So mounting a compressor on an arm is possible.
It is possible. It's not wise, but it is possible. Whenever you're doing pneumatics in the future, the biggest aspect is to say, how can I make this safe for myself and my gear? Because as soon as you crash your gear during a competition, you got to replace that real quick. And I'm guessing a lot of teams right now are new, so you guys got that pneumatics kit that comes with a lot of this stuff.
No, I mean these are mainly from established teams, but they're new to their teams.
Oh, new to their teams. Okay, so all new teams, brand new teams, they get a pneumatics kit, and that comes with a lot of the stuff we're going to go over today. But even if you're not a new team, you can order another pneumatics kit, and it comes with all the stuff all over again. So this is your pressure relief valve. It's kind of, like I said, it's one of those tedious things. It's self-explanatory. Pressure release valve, you twist it. Actually, it's right on here. If everyone can kind of sort of see this. You basically use a wrench or your hand to twist this open to allow pressure to come out. The pressure release valve is always important to put on the robot because it has to push air back out whenever something goes wrong. I'll explain why a little bit later when we get into pressure switches. But if you use an off-board compressor, then you do need two valves. One being connected to the compressor itself, and one being connected within your pneumatic chain further along the line. This is your pressure switch. So it opens at about 150 psi and it closes at 95 psi. This basically says that with the pressure switch, you don't have to constantly keep worrying about, okay, am I running at a constant pressure? Am I running at exactly 120, or is it lowering or whatever? This kind of does it for you. It's smart enough because it's programmed into your PCM. That's what the pressure switch slots are for. So,
And they're also often called the Nason switch.
yeah, that's also
That's the company.
That's a very good point. The PCM turns on the compressor automatically due to the pressure switch. So if you're in the middle of the competition and you don't have a pressure switch, first of all, you won't be able to compete, but you still that's kind of the reason why we put a pressure switch on there. So that way the compressor automatically turns on during the match. You can code that into your robot as well. Next is your air tank. Your air tank is different from the compressor. It stores your air, your 125 psi. One thing I want you guys to kind of keep in mind when putting an air tank on your robot, do not put it in an enclosed space where a lot of things are turning on your robot, and do not put it somewhere where your robot can be impacted, such as near the bumpers. Because when you put an air tank on the robot, the air tank is made of plastic. Plastic is easily bent, deformed, shattered, or anything of that caliber in a competition. So keep that in mind. Also keep in mind when putting an air tank on, you'll see on the ends of the air tank, you have fastener spots. When you put those fasteners in, you do not want to put a lot of pressure on there. Basically saying, even if you're hand turning it, be careful because the torque of your hand is still higher than the torque that plastic can withhold. So basically you'll break the threads going in. Your regulator. So your regulator basically, as it calls out to be, is regulating the stream of air flow going through your pneumatic system altogether. The regulator has a maximum output of 60 psi, which you will know. Mark that in a second. The pressure gauge. Well, there you go. So here you have your regulator all together here, but then you would always need to put a pressure gauge on your regulator. Why? You want to know how much pressure you're building up inside. The regulator regulates exactly 60 psi going from wherever you connect basically the compressor to wherever you're going to end up at.
You can go under 60 if you want to, but if you go over 60, then you'll fail inspection.
Right. Good point. So the main point of the regulator is to relieve pressure increase. So as you're working through your robotics competition, as the pressure is building up, this is helping you push out that air while your compressor is being on. So think about it like this: your compressor is running at 120 psi, pushing that throughout your entire robot. Once it gets to the regulator regulates 60 psi of that to basically be pushed out back into your relieve over here to basically push that out constantly. Why? Because the compressor is a never-ending air increase. Yes, it pushes out 120 psi, but you keep forming 120 psi over and over again, you're going to get a buildup and we're going to have to shut you down. Solenoid. So your solenoid is your electrical components when it comes down to your pneumatics altogether. The reason why we use solenoids is because that actually helps us push. What? Just put. It helps us push our actuators, push our cylinders, things of that caliber. So this particular one. Sorry about that, guys. But this one in particularly, if you connect it to your solenoid sends that air that pushes it out, which goes through this cap here, pushes it out so it can do its job, and then doesn't have one in here, but you will put another valve fitting in here, and that would pull the air back out, which will basically in turn pull this back in.
So the solenoids are basically like switches allowing the
Right.
air compressor to go on and off.
Exactly. Well, not the air compressor, but
The airflow
right, exactly.
to actuate that.
Exactly. Remember, with pneumatics, all you have to think about airflow. When thinking about airflow, you basically say, which direction do I need this to move to make it work? So, There are two different types of solenoids. One is a single solenoid, one is a double solenoid. Anybody can think why we have two different ones before I kind of explain it. I kind of want to interact with you guys because you guys are giving me that stare. And if I wanted to be in class, I would have stayed in school today. So,
Maybe one of them is regular the flow going in and out, and one of them is just to like go for one direction.
that's exactly right. That's exactly right. One goes in one direction, which is a single solenoid, and the other one goes in one opposite direction, which is the double solenoids. So my example for that would be this thing. Back when I was a Kettering student, I made a double action cylinder to basically do resistance in both directions. That's why you see this chain right here. I'll explain that a little bit later. But if you're using a double action cylinder within your robot itself, you want to use a double solenoid. Why? Because you want it to be able to go one way and go the other without coming back to that rest position unless you need it to. And you can code that directly into your robot. Most people use just a button, like your X button or R2, R1 for people who like to use Xbox controllers, things like that. So, any questions so far before we move on about solenoids? Because it's easy to put together, but it actually can mess you up when coming down to running your pneumatics if you don't know which way you're really going into. But we'll explain that a little bit later. I just kind of briefly explained gauges before. Your gauge shows your pressure of both your stored and your working system.
What's the difference between stored and working?
So your stored can basically be mounted anywhere upstream of the, upstream of the working pressure. Yeah. I have it written there. Okay. So with your working pressure is everything past the regulator. Anything before that is your stored. So once you pass that regulator, you're pretty much, that's why we say you have to have both gauges, one for your release valve and the other one for your regulator, because that's the working to the stored connection.
So all air pressure before it is working and all air pressure behind the stored?
All air pressure after is the working. Stored is before you get to your regulator.
Which is 120.
Once you get to your regulator, it goes into working mode to push out to 60.
And the working is less, 60 or less.
Right.
That's what actually runs your cylinders.
So, park fittings, a lot of you guys might know what that is. It's just literally fittings that's connected to the robot itself. I really want to go over this because I've seen a lot of teams do this, and it's not that it drives me crazy, but it is going to mess up your robot in the end if you don't follow this nifty rule. All hard fittings must have Teflon tape. Every single one of them. This would be considered a hard fitting because it has hard threads on there. Basically anything made of metal or has a unique set of threads needs Teflon tape. Okay? These are push to connect fittings. So basically you just push the tube in, but you got to push in there and feel that it's like a small tiny pressure that pushes it in again in order to feel the full connection. Then you can like tug on it gently and you can know that it's fully connected. Or you can run air through it, and if you don't hear any whistling or leaks in there, then yeah, you got a good thing going.
Or soapy water. Or use soapy water and see bubbles.
Or yeah, soapy water is definitely the big thing. So anytime you make a connection and you hear that airflow, you hear the leak or anything like that, just grab some soap, water, like a pipette or even like a squirt bottle or something, and just spray your
If you're
tubes
not
down.
sure where it is.
Spray your connections down, and wherever the bubbles you see it, that's what you need to fix on. That's actually why we use Teflon tape. All hard fittings must use it. This right here shows you a good guide what to do when it comes down to Teflon tape. So with Teflon tape, the first 2 threads should never be covered. Never be covered. Why do you think that is?
Cross thread?
Hmm?
Cross threading?
It could be part.
Okay. If it's too close, might plug the hole up.
Yep. That's our main thing. If you use Teflon tape, it's too close to the beginning thread, it'll overtake the thread, go underneath, and it's gonna be a mess in there. It's really gonna be a mess, which blocks your airflow, and then you're gonna be like, what happened? And then you gotta clean out threads, and it's gonna be very slow. So yeah, only do it after the first 2. If you see any bodies that looks like this, you know, big cancel outside, no bueno. So, this right here is your plug valve. Most people call it an emergency valve, but you must install this. You must have that at an easy location of the robot, because if anything happens and it's like an extreme buildup of pressure, your pressure switch stopped working, so it's just constantly building up and stored energy without releasing it. On here, it's a small black one, but you just basically turn that, if I can, and it releases your air outward. And it's in an easy location. It's on the compressor for me, because at the time that we used this, we had access to the compressor. So I'll let you pass that around if you want to, so people can see that.
You can turn the valve. You can turn the valve if you want.
Yeah, I know. I closed it, but so to learn how to make sure a valve is opened or closed. If it's like this, it's open. If it's turned to the side, it's closed.
Yeah, that's right.
Okay? Any questions, comments? Last but not least, your cylinders. You really get free reign in FRC when it comes down to cylinders. You just have to follow the guidelines. So Bimba supplies multiple cylinders that you can use, which you can change the stock, which is the length of the, not the stock, the stroke. You can change the length of the
Stroke.
stroke, yeah, that's basically what it's called. You change the length of the stroke throughout the season. If you need a small stroke, big stroke, longer stroke, whatever, you can change it. You can change it very easily, and then you can change the bore size, which is that diameter of your cylinder itself.
Yeah, in the past, every year you get a certain credit for buying Bimba cylinders.
So that's a good thing to remember as well. Credit.
Use it.
Use the credit. So also for different cylinders, if you ever want to take a look at it, I've attached a link to this PowerPoint here. Like I said, I'll be sending it to your mentors or head coaches of the team. But yeah, right there, Kit of Parts shows you the multiple cylinders that you can get from FIRST just by researching the Bimba cylinders. Any other questions? No? All right. So now we're going to step into how we actually put this thing together. The reason why I didn't go and kind of explain tubing, because tubing is pretty self-explanatory. Your outer diameter must be quarter inch thickness. So you get points. The outer diameter should be 0.25, where the inner diameter should be 0.16, I believe. So that way you have a good constant airflow. Those are the things that actually fit your fittings that you get in your kit of parts. So remember 0.25 diameter tubing whenever you're using kit of parts. This right here is 0.25 diameter tubing. Normally I can kind of touch a tube and tell what the size is, so that's kind of how I learn. Alright, but first let's talk about the compressor and the relief valve. So your compressor, your relief valve must go on your compressor. As we've already talked about before, the Teflon tape must be wrapped around the hard fitting. So the hard fitting goes inside. Your hard fitting goes inside of your end compressor, because this is what we like to call the, if we worked at FANUC, we would call it the exhaust, the exhaust air hole. or the exhaust valve, but in FRC they call it the relief valve. So you put it in the relief, it kind of builds up to look like this. Back in that kit of parts, back in that part fitting slide, I showed you guys the different part fittings. This is a T-thread part fitting, basically saying that your hard fittings are going to go inside, in, and in. None of them will punch out. You'll screw those all in. You see the white around there, knowing that Teflon tape is on there. That's another thing that's very important. If you twist this in here and it doesn't go all the way, that does not mean that the fitting is not in. It just means that the Teflon tape has reached its limit. You don't need to keep screwing it in because you can mess up the threads. I've seen a lot of teams constantly go for the twist because you get that one strong guy who can keep twisting as much as possible. Don't let anyone over torque your threads. Other than that, you won't have threads to torque. So the release valve goes up, pushes it out, pushes air out. So here are the actual step-by-step guidelines that I actually use from the pneumatics guidelines that FIRST gives us. So this is literally step-by-step. You follow those steps, you'll be great. In the later part of the class, you'll be able to actually put one together, as well as identify the ways that these are put together. That's kind of what I want to make sure you guys know, is how to put them together, and if somebody says, hey, I got a problem, you can troubleshoot your way through. So like I said, if you have questions, please make sure to ask. Step 1, install the hex nipple to the compressor itself. Hex nipple. That goes on there. It's very, very easy. This is an example of one, but this has a push to connect fitting on there. So for all those who can kind of see that, it's right there for you. Once you put the hex nipple on there, you want to connect the union T, which that's what I was calling the hard fitting T. But yes, this is the union T, which you connect using a hard fitting, double threads going out on both sides. Just use yourself a wrench, adjustable wrench, put it on there. It's very easy. Connect your adapter to your union T, right here. Connect the adapter. Going up for your relief valve. Very, very easy. And then you also want to make sure you connect your male connector, which will be here, to push. That's kind of your, tube connection to your robot. Well, not your robot, but your pneumatic system. So that's where you're going to start your tube connections, right through that fitting there. Here's a couple notes. Secure all your connection points. Make sure you use the Teflon tape. And the pressure relief valve does need to be calibrated. I'll show you how to calibrate it a little bit later on. But it's basically, just for the sake of time, all you really do is open it, let the compressor run at 120 psi, and then once it's done calibrating, you close it. So, number 2, your pressure switch, your gauge, and your plug valve. Very, very easy to put together. You have your, so if you want to work backwards or whatever way you want to do it, you can. You have your plug valve here at the very start. So remember always that the one with the adjustable horizontal, vertical twist, that's your plug valve always. Put another hard fitting connector on there, Teflon tape. Your union connector, your union T. One goes into your gauge, which you guys have seen many occasions. And then one goes into another union T, which goes into your pressure switch. And then back out through another push to connect fitting. Now, where do you think that push-to-connect fitting goes to? To the other push-to-connect fitting. So, it's pretty easy to put those together. Whenever you do pneumatics, if you're using a push-to-connect, you gotta put it at another push-to-connect. So, push-to-connect to push-to-connect. Hmm?
Can you just do it all the way through?
You could if we didn't have regulations saying that something has to be in between it. Yeah. So I know that's actually what I would like to do, but even over at FANUC, when we run tubes through our robots, we actually have to have multiple things that stops it. Because if anything happens, like an enclosed robot gathers a lot of heat, we have to put a purge line in there in order for us to push air throughout the robot. If we don't have that purge line in there and just run directly through, we'll get an overheat air, or the robot will actually blow up. So we kind of try to avoid those kind of things. So, I'm not gonna read all the steps to you guys. That way, you guys can get the joy of reading it yourself when I release this to you. Trust me, it's actually very easy. When I say step by step, this is legitimately step by step. So, any other questions before I move on? Yes, ma'am.
All the way at the end, next to the gauge, is that the pressure switch?
This one?
No, up,
Oh, that's a pressure switch.
right there.
This is the pressure switch, yes.
Okay, thank you.
Yep, that is the pressure switch. Anyone else? Fantastic. So, no, I didn't change the title. This is your regulator, not your pressure switch gauge and plug valve. This is your regulator. Your regulator, as you remember seeing it, it didn't have all the connections put on there. One connection is your gauge. Have to put a gauge on the regulator. Other than that, you can actually just plug in cap offs if you're not going to use it for anything else. So in a couple examples, I'll show you guys what other people have used in order to push their regulator kind of to the limit, I guess. But that's kind of how you put your regulator together. Pressure switch goes in one spot. These other spots, you can either put a push-to-connect fitting and put something inside the push-to-connect fitting in order to stop the airflow from going out, or you use those push-to-connect fittings. Another good tip when using tubing altogether, if you're not going to run air through a certain part, like in the regulator or anything like that, if you put a tube in there and just kink it and put a tie wrap on there, that's acceptable. It'll stop the airflow. Instead of trying to always find a stopper that goes into the push-to-connect fitting, just put a tube in there, kink it, tie it, and just tie it over. So,
Not many people do that, but yeah.
not many people do that unless they're in a pinch. But you know, any questions on regulator assembly or regulators in general? Okay. Now you get down to your actuation. So attach your elbow push-to-connect fittings. So your elbows, I mean, it literally looks like an elbow, so get that L shape push-to-connect fitting. The hard fitting part goes into the actuator, and then the push-to-connect fittings go into your solenoid. So I'll make sure you guys know how to put a solenoid together, so that way you can connect those in the long run. All right, solenoids or electrical valves. Very easy, very simplistic. You screw in all three of your push-to-connect fittings into ports 1, 2, and 4. So let's show you where those are. You have 1, 2, 3, 4, and 5. Why they did it in a diagonal, I cannot tell you. But so 1 is in the middle here, 2 is over here to the right, 4 is over here to the left. Put it just like that. Why do we do that? Because from your regulator, when you have that tube coming out, goes into this bottom part of the solenoid. And from that goes through these two parts of the solenoid, one of them going to the end of your one part of your actuator actually doing something with it, and the other part going into the other part of the actuator releasing the air coming, well, after you get done using your actuator, I guess. So I probably didn't explain that in a coherent thing, so.
And a lot of times they'll have more than 3 outputs. Sometimes they have 4, 6.
Right. So solenoids can come in many different ways, shape, or form, but just know that a solenoid is something that connects electricity. That's why we have the solenoid connectors inside the PCM. If you're using a double solenoid, a lot of teams, I don't know if a lot of teams do this, I normally do it. I connect the solenoid right next to each other. So from 0, 1, and 2, 3, and 4, just go straight down the line. It's going to be connected that way anyway. Then when you do your coding, solenoid 0 opens when solenoid 1 closes, vice versa. So, any other questions about solenoids or anything like that? It's going to all make sense when we get to actually putting it together. All right, let's put it together.
Straight into it.
All right, straight into it. Yeah, exactly. So, this is the best way that I can say putting anything together. Tubing is easy. One thing I want to warn you about tubing. When you're putting tubing together, unless you mean to kink the tube, don't kink the tube. Because when you kink the tube, it wears it. Wears it out very, very good. Now 120 PSI, that's probably not enough to make a burst, unless it's directly at the fitting. But
Try not to kick.
just try not to kink the tube. If you do kink the tube, replace the tube. Don't try to unkink it. Don't grab like a pair of pliers and just make it be that round shape again. No, just replace the tube.
Tubes are cheap.
Just electric tape.
All right. The
No,
reason why we
it's
say
actually
that is
not
because
legal.
unless it's bolted down like you see here, that tube's gonna fly everywhere. It's gonna hurt somebody. If you don't have to use a super long tube, I recommend it.
This is just a example where you see like the joints at where the tubes at. You want to pre-plan where you're going to use your tubes before you actually install anything. One of the worst things that I've experienced is if you don't plan out and then you just tube everything out, it's going to really, really suck when you have a leak. You got to go through every single piece to find out where that leak is, and that can take hours.
Yeah, that's another thing too. Altogether, another part that I recommend all teams to do is I call it hose bundling. Whenever you create a structure like this, or even a more difficult structure, whatever tubes are relatively close to each other, like say for instance, instead of us being straight across like this, if I have another actuator and another air tank, but they're right next to each other, but I got tubes flying everywhere, just grab a zip tie, kind of put them together. You don't have to pull it tight, just put it together, have that hose bundled. That way you know where everything runs into, and then everything looks clean. The reason why you want everything to look clean is because that way you know where your routes go.
You probably want to label it too.
Yeah, labeling would definitely help you out as well. Label makers, I don't know how much it costs because I don't buy it. I normally just get a piece of masking tape and write it down.
The center purchased one if anybody wants to borrow.
Oh, see? Yeah, there you go. But let's actually get to how we put it together. So I need a volunteer who paid attention. Okay, we got one. Who's another? No, go on.
I don't know where to go.
Here. Need two volunteers who have not been on a team before.
Somebody new.
Oh, Ian.
Go in.
Go in.
All right.
Oh, another Ian.
What you even talking about?
Oh, another Ian.
There's two of them.
Oh,
So
man.
based on what
Two
you
Ians.
know,
Sorry,
from
forgot that.
when we started off with, from here, how can we get to this full connection?
We must collect the parts
Collect the parts first, okay. So what parts do we need for particularly this? I just want you to point it out. We're not gonna build it because I don't even think we have a lot of parts for me to build anything. But using this,
Solenoid is the only thing
so from the
I
PCM,
think we're missing.
from the PCM, I connected my compressor. From the compressor, I made my release valve. Right.
You guys want to get up and look at it?
So from the release valve, I go into the pressure switch, right? Pressure switch must always have a gauge. Yep. Exactly. Emergency valve must be placed on the robot, right? But anyway. Yeah, that's what you got a point there. In the event that I'm going from the pressure switch onward, how much PSI is going from the compressor through the release valve, through the pressure switch, all the way to the regulator? 60 or less?
Around 120,
Around 120. Why?
because that's
Has it gone through the regulator? And what kind of air is that? Not working.
I was gonna say
Storage,
potential.
exactly. Stored air. So from here to the regulator, that is all stored air. Once I get to the regulator, that becomes working air. Exactly.
Okay, most inspectors will ask you about that.
Yes.
Make sure you know what.
That is why I'm quizzing you now. So I don't want you guys to be like me my freshman year of robotics and just kind of stand there and go, well, they told me to put it together and I did it.
So you do it.
Well, another thing here, this regulator, it pushes out a total of 60 if it's all the way open. You can actually twist this thing to adjust your,
That's where I got the system first.
yeah, you can twist that thing in order for you to adjust how much pressure you want to put out there. So if you want 50, twist it to 50. If you want 40, twist it to 40. But you can twist that thing. I mean, I can't now because it's not really stationary for me to twist it. But all you have to do is really follow the arrows. The arrows are located on top of the valve on the regulator itself. Once you follow the arrows, arrow going away closes, the back end of it opens. Okay? So why do I put a gauge on my regulator?
And so you know it's at the right.
Regulate
Question.
gauge,
To
gauge the regulator.
not gauge the regulator,
To
but
like tell what's happening.
a little bit more detail than that. You were going somewhere when you said regulate. What am I regulating?
Airflow.
You're regulating your airflow, which is the,
Okay.
starts with a P.
PSI. Are you sure?
There you go. That's the unit of measurement. That's a unit of measurement. So,
Force divided by area.
force divided.
Oh yeah. It's not going up.
Regulating the pressure, that's doing what? That's
That goes
Side.
into your, that goes into the side post, which either one goes into one solenoid and the other goes to another solenoid. But if I don't want one to go into anything, what do I do with the two?
Cap.
Say it loud.
kink it and tie it.
Can't get it tied with a tie back.
Couldn't you also just put a valve
Zip
on
tie.
it like this?
Huh?
Couldn't you also just put it to a
This is
valve like
the
that?
this is the emergency valve.
Couldn't you use it on the valve like that just to shut it off?
You could do it for your emergency valve because I mean it's actually no.
I mean, couldn't you do an additional valve, I'm saying?
Oh yeah, you can always put you can put mini valves on there
Yeah.
as much as you want, truthfully, but you just kind of need to know which valve goes into where. So say like your
There is a limit
It's
because
like
Oh,
having
yeah.
you start gaining storage.
storage here.
And
So
Okay.
say for instance, you are making a combination robot, offense and defense. You run pneumatics one way for offense, you run pneumatics a different way to run defense. If a valve on your regulator, if you put a valve here and a valve here, one saying offense, one saying defense, you can close one while running the other. And it runs pretty smooth. So just think about that in the future if we do have like an offense defense kind of game come next year. The game changes, so
It's Steamworks though.
yeah, it is.
I need to get an address for that.
So your switch here is wired to what?
So your switch is wired.
There's
So
only one wire going in here.
well, this is not a good example.
Okay, this was taken apart by,
Right, this was taken
Yeah.
apart.
so,
So
someone took a few parts away.
this here, these are your pressure switch. Remember, pressure switch wires. Pressure switch wires go into the pressure switch connector.
Does
Which-
it matter whether it's, which one red and black go into?
No. As long as you put it in there, right
Okay.
next to each other,
And
because
how
there's
does-
only two.
How does the pressure switch work then? So you've got 120 in this area, and what's the pressure switch gonna do?
The pressure switch is okay. The pressure switch automatically turns on when the compressor is on, because that's the way that the pressure switch is built, and that's the way that your program's gonna register the pressure switch when you run pneumatics.
So just, it's gonna power it on through this pneumatic control?
Right.
So when
That's
pneumatic
why-
control
that's
is
why you have
powered
to-
up, and
Well-
when the compressor's powered, then this is
So it
also
opens
gonna be
and
powered.
Closes the
Right.
circuit.
But the only way that it closes the circuit is if it's connected to the CAN bus in the back, which that is connected to the Robo Rio. If it is not connected to the Robo Rio, your pneumatics won't do anything. The compressor won't even turn on.
So we've got, the can is going to the Robo Rio,
Correct.
and that's, how many wires, just 2?
Depends.
Okay.
Really depends. So, I actually have, I don't have a full thing of the Robo Rio, but I can kind of get to where I need to be.
There's a Robo Rio right on that computer. You can look on that robot,
yeah.
robot right
No.
there.
Oh, okay. So yeah, we can look at the Robo Rio on the robot and kind of show you where we can go with it.
Got your way. Right there.
So this is the Robo Rio, as most people know. Oh, they were even nice enough to put something that looks like a PCM right next to it. This is not a PCM. This is a different.
It's a
whole different-
voltage regulator.
Yep, this is the VRM, voltage regulator module. But so the Robo Rio is here. If I can.
There's a
find-
can thing.
There we go.
It says can.
I am falling backwards. But anyway, from your CAN switch here, you have a green one and a yellow one. It says green and yellow on the Robo Rio. Green goes to green, yellow goes to yellow. Do not invert it by
Okay.
any means. That is the way that you get your connection to the Robo Rio. Once that connection is made, your compressor is ready to rock, meaning your pneumatics is gonna roll.
I want to invert them now and
Huh.
see what happens.
Nothing. Absolutely nothing happens.
The circuit doesn't work at that point.
It just starts to burn up and heat up, and then your Robo Rio is gonna be mad at you.
Take 9 volts.
$430 later.
400. Yeah.
Before it explodes.
So let's get down into the CAN wires. When we said this, it even has the colors right here: green with green, yellow with yellow, yellow with yellow. Can you have more than one can? Technically, yes, but
Shouldn't you?
Why would you? What are the reasons why you would?
Well, can is used for other things.
right,
Can is used for sensors too.
right. So basically,
Or your motor.
you have.
string.
So basically, from your Robo Rio, you have to put a set of cans in there. From that, you can put it into a sensor, or a motor, or anything else in between, but you gotta make sure it's connected correct. Pressure switch goes into that blue tag that's on there, which is labeled pressure SW.
So again, going back to this pressure switch, as the pressure rises, I mean, it's on as long as the pressure is below what? Doesn't the pressure switch get up to a certain
So,
point,
yeah.
and it opens, and
Yeah.
then it closes?
Then
when
it closes.
comes back
So
on?
the limits to those, as I think I said it before, it's open at 115 and it closes back at 95.
So when the pressure goes back down to 95,
Then it closes and builds
meaning
back
that
up.
the current's flowing, the compressor's on, but then it'll creep up, so there's hysteresis
Right. So the reason why it does that is because going into the regulator, you're going between that 115 to 95, going into the regulator. Regulator pushes out 60. If I push out just 120, and the regulator just somehow, some way starts storing inside the regulator instead of having an even flow coming out, then we could have a problem. So the pressure switch basically says at 115, I'm getting close to my 120 limit that the compressor builds. So I'm gonna push some of this out. At 95, okay, that's a little bit too much, so now I'm gonna close it. That's why you have to calibrate your relief valve.
So it's kind of like an iris, right?
That's a good way to look at it. That's a very good way to look at it. I kind of looked at it as like, you know, the pulsing metal thing, but then again, I made that up when I was like 14. So, yeah, I'm not 14. Let's see. We have your 12 volt, your ground. You kind of know where that goes into. It goes to the battery, which goes here, which on here is to the side. It's kind of like the PCM is very self-explanatory. Everything's labeled, everything's colored. So when I give you this instruction, you can literally build anything you want with pneumatics. I recommend pneumatics always because, like I said at the beginning, the weight distribution between a pneumatic lift compared to like a chain drive lift, completely different. I can lift using as much force with a pneumatic system than waiting for a chain and a sprocket to come back up. Now, pneumatics do have its kinks just like chain and sprocket, but I'd rather deal with an air hose than a chain. One, a chain's link can break anytime during competition. Two, I have to keep it lubricated. Three, I have to make sure that the chain and the sprocket have similar gear ratio in order for it to actually lift anything. So you have to calculate a full-blown gear ratio in order for that to even happen. That's a lot of work. I'm lazy. I'd just rather put air tubes together and say, okay, that works. Now, I'm not disadvantaging anyone who likes chain and sprockets. I've used it a couple of times myself just to prove a point.
Well,
But,
yeah, pneumatics can't do everything.
right, pneumatics cannot do everything. Pneumatics only go up to 120 psi. Chain and sprocket goes however powerful that motor is. So,
Or the gear ratio.
right, or the gear ratio. So if you have two small sprockets labeled up and good example would be a couple years back we used a bunch of connects. And everyone knows what connects are, like the, I guess, like angle version of Legos. We put a bunch of connect sprockets together, and this was when they were teaching us how to calculate gear ratio. We made it climb a ladder. Pneumatics can't do that. Pneumatics can't climb a ladder unless you literally just have a bunch of tubing that goes in and out and in and out. But the thing is, it won't actually turn and rise and grab like that unless you make a rotating pneumatic system.
You can, yeah.
But you might as well make chain and sprocket at that point. So, moving forward, this is one thing that I wanted to make sure you guys know. So just like you see on here, the way that this pressure switch is connected is through, I want to say eyelets. It's a ring or spade you want to use on those in order for you to put a screw in there and tighten it down with a bolt. The reason why we do that, because, you know, metal conducts electricity. So it's kind of self-explanatory on itself, but that's the way you have to connect it to. Well, I mean, there's many ways you can connect it to the pressure switch. That's just the easiest and most cost-effective. So let's kind of wrap it up a little bit. So the software, I am not the software guy by any means, so I cannot really go into much details. But you have to update and configure your PCM and your PDP. Who remembers what a PDP is? I think you guys learned it in the electrical.
Well, they haven't had electrical yet.
Oh, they haven't? I thought they did earlier in the year. You know what a PDP is?
Was it that thing on the side of that? Was it for power distribution?
The power distribution.
Yep.
That is correct.
What does the last P stand for?
L.
Oh.
It has an UL.
I
We're
didn't say
supposed
that.
to look at it.
Didn't say that.
You were
No,
not
you know
supposed
the answer, so.
Yep.
But yeah, the power distribution panel and the ag control. Actually, in reality, since I got a lot of minutes, I can crank that open for you guys so you guys can kind of see what you will be in for. I gave you this link because this link is literally the step-by-step of how to run. Let's see, did it actually open? Is that it? Nope, that's not it.
University of Colorado.
Go away. What's this? Doesn't want to come up. Okay, this is the actual manual. So I'm going to actually be sending you this. I don't think there were any changes between the 2015 and 16 instructions.
I don't think so.
It should be exactly the same. The one that I have is 2015 because I just needed to get an updated version. Shows you everything I showed you. Actually, in reality, I made this PowerPoint based on this. So it's all right there. It's all right there, huh?
The abridged version.
Yeah, pretty much. I try to make things go faster because I like sleep. Okay, that's not what I want either, and I don't want to retry it. So, literally, step by step. You are talking about your relief valve and your pressure sensor. Pressure sensor regulates between, well, not regulates, but opens the valve at 150. Oh, yeah, open the valves at 115 psi, close the valve at 95 psi. And keeps doing that throughout the entire competition. So how do you do that? Loosen the lock nut on the relief valve. After that, jumper the bypass of the pressure switch so that the compressor runs continuously. Who knows exactly what that means when I say jump the bypass?
Okay, good.
Get some guys to beat it up.
That's one way to do it. Yeah, that's exactly.
Add electricity.
Go around.
There you go. You go around, basically. So you go around the pressure switch, basically saying that, okay, I know you're supposed to go 115, 95. I just want you to run at full capacity without even thinking about it. And you can do
So
that.
how do you jump for it?
Okay. So,
You gonna use a wire or what?
You wire it across the switch terminals or at the?
no, you kind of leave the same connection going in. What's the best way to explain this? Haven't done it in a while.
What are you trying to do?
Jumper the pressure switch.
To calibrate the pressure relief valve.
Remember, we got to
The
jump
way-
the bypass.
Yeah, the way the judges do it in the pits, or to prove it,
Right.
they just take an insulated handled screwdriver and
That's why I said
Pretty
you
much.
can do with a wire or a screwdriver.
yeah,
Across the switch.
across the terminals, yeah.
Yeah.
On the switch.
Not all inspectors do that, but we're supposed to.
Right?
You're just jumping those two terminals on the top of it?
No, he has a point.
What?
When doing that at all times, make sure you are grounded and you
Yes.
have something between you and the metal.
I personally don't like to do this.
So
I don't
basically,
want to do
But
that.
that's how.
so
I've
basically,
seen them
what
all.
I recommend, what I've
Every
recommended to the
judge has
mini
done
team,
Every inspector.
what I've recommended to
Yeah.
mini
That's
teams
right, yeah,
is
every
when you're
inspector's
doing
done that.
this type of thing, even if you have a plastic handled screwdriver, get some kind of rubber,
Insulated.
insulated rubber.
Insulated handle is what you need.
Right.
Yeah. They
I think
make,
last time, what did we do?
they
We
make
put like a rubber
They
cover
make
on it.
screwdrivers rated for
Yeah.
rated for this.
You can actually do it that way, whereas Mark has said you can actually grab a wire and do it. But basically, you're tricking the pressure switch.
Heavy gauge wire.
Yes.
Yes. So
Number 10.
just like we're basically saying is you're tricking the pressure switch to say, oh, I don't have any commands. That's kind of what it comes down to. Now, if it gets to the point where you can just code it to go through calibration, that'll be beautiful. But I have not heard of anyone doing that yet. So when the pressure gets up to 125 psi, aka read the gauge there, remove the jumper. Rotate the cap until the air escapes and the pressure remains at 125. And then, finger tight the lock nut shut. And then dump the excess air out. If it doesn't work that way, just redo these steps again. It's
It's not an exact science, but it's
but it is proven that it is working. I recommend that if you are a student, to make sure a mentor is with you while you do this, or just have the mentor do it, because I think more mentors have life insurance than students. So,
Maybe.
surprise.
It'll hurt.
It'll hurt. Oh, yeah. We've experienced that one.
It'll hurt.
Yeah. If your heart has stopped, we'll get you back. So,
So when you jumper it, are you just connecting those top two terminals? Is that what you're doing?
mhm.
Okay.
That's it.
That's pretty much it. But, any questions on the calibration? Like I said, everything is written step by step. Just do it. So here are more resources. One of them you kind of briefly saw, which is the Robotics website. Well, they do a very good job on their pneumatics course, but they just don't use the actual they don't use the actual robotics pieces. They just use drawings that they make on Word. So if you want to run through it, I can show you it because they
I'll do that when you go.
Okay. That was pretty much going in there. Another one is Cage Engineering, which I believe is Team 2138. They made a good presentation. If you ever want to just run through to what you can do as a robotics team pneumatics system. Then for wiring, this is another step-by-step guide of how you would wire your PCM right there. So at this point, since that is the more sources, I'm guessing I have nothing else after that. Any questions on pneumatics in general, or tubing in general? Here's another thing too. This kind of looks like a Jungle Fury thing going on down here. One thing about tubing, if you're running CAD anytime, I would CAD yourself tubing. What I mean by that is connecting, when you're assembling, connect a spline from one product of pneumatics to another, make a tube, and then measure out that tubing. Because then you can actually get good exact tubing in there, and you don't have excess tube. And when you zip tie it down to the plate or anything like that, it'll look good. You'll be good, basically. Yeah, because if, like, say for instance, you have a bunch of gears running in there, or even other pneumatics running in there, as it's running, it's moving the tube. You only want to move the necessary amount without it getting in anything else's way, getting stuck in a wheel while you're driving across the field or anything of that caliber. Another thing too, a lot of teams, they do this because of cost. I don't recommend it. Buy yourself some good tie wraps. Do not just buy cheap tie wraps. I'm very serious. Do not go to the dollar store and buy tie wraps. Go to Home Depot, Harbor Freight, do something. If you're gonna spend money, don't do that either.
Yeah, because they break.
Yeah, don't do what we did one year and everybody go buy like 3 loaves of bread and we all used to twist ties off bread. We have done that. We have done that. So it actually worked for 2 matches and then we couldn't find them anymore. So they are not heat resistant. Tie wraps are. But yeah, go get yourself some good tie wraps. Do not sugarcoat tie wraps by any means.
Yeah, we use good ones. We had one batch that we had that they broke every time you used them.
Yep. See,
We don't know where we got them from, but
the dollar store.
Either we bought them or they gave it to us.
yeah.
It might have came in the kit. Who knows?
Yeah.
But at
But
the
they were
same
bad.
time, if they got thickness to it, like I want to say like 3/4 of an inch.
If they're really old, they'll degrade a little too.
Yeah, that's true. Don't let them sit around for a while. But, you know, 1/4 inch thick, be good. Even a little bit of half of that would probably be good. But any other questions on pneumatics? Any other thoughts that you may have on what you want to try with pneumatics? I could possibly give you a yay or nay on it. Give you guys a good thing going.
Why is he videotaping this?